Objects experience an upward pushing force when they are submerged in a fluid. This force is known as the buoyant force. You can see the effect of water's buoyant force acting on this rubber ball. After the ball is released, the buoyant force pushes it up towards the surface. When placed in a fluid, an object will either sink or float depending on whether its weight is greater or less than the buoyant force. For example, the weight of the softball is less than the buoyant force. As a result, the ball floats to the surface. Here, the weight of the scuba diver is greater than the buoyant force, so it sinks to the bottom. If the weight of an object is equal to the buoyant force, the object will neither sink to the bottom nor float to the top. For example, this submarine has a weight equal to the buoyant force acting on it. That's why it's not sinking down or floating up. But what exactly is buoyant force? Can we actually measure the buoyant force acting on an object? Yes, we can, and here's how. Remember, the buoyant force is equal to the weight of the fluid displaced by an object. By using this overflow container, we can capture the displaced water. The weight of the displaced water will equal the buoyant force pushing up on the apple. When we compare the weight of the apple with the weight of the displaced water, it is clear that the displaced water is heavier. Since the weight of the displaced water represents the buoyant force is also greater than the weight of the apple. The apple stays afloat because the upward buoyant force is greater than the downward weight of the apple. In this example, a brass cube is placed in the overflow container. We capture the displaced water and compare its weight to the cube's weight. When we place the brass cube and the displaced water on a balance, we see that the cube weighs more. Once again, the displaced water is equal to the buoyant force. Since the displaced water weighs less than the cube, the buoyant force is also less than the weight of the cube. The cube sinks because the downward weight of the cube is greater than the upward buoyant force. Here we have a ball of clay that neither sinks to the bottom nor floats to the top. When the clay and the displaced water are placed on the balance, we see that they both have the same weight. This means that the buoyant force is equal to the weight of the clay. The clay appears suspended in the cup because its downward weight is equal to the upward buoyant force.